You're listening to All Things 3D, where we talk about the world of fabricating, designing, and capturing in the third dimension.
All right, welcome to All Things 3D, Friday episode of 3D in Review. The week is January 23rd, 2015. I'm your co-host, Chris, along with...
Mike. That's my name, Mike. I even have a little lower thirds now, so you can see my name. See, it's right down there. Mike Balzer.
All right, and we've got all kinds of really exciting stuff that happened in the news this week. We're going to just get right into it. Yeah?
Now let's talk about 2015. Here we go.
2015.
Hey, pizza.
All right, just wait.
When it's ready, can you just shove it in my mouth?
Don't you be a smartass.
I want
I'll
one
break
of
the
those.
atrocity channel.
Hydrate level 4, please.
Is it ready?
Here you go.
Oh boy, Mom. You sure can hydrate a pizza. I'm sorry, I missed that whole thing.
Al, I'm just worried about Jennifer. Why isn't she home yet?
I'm not sure where Jennifer is, Mom. Should have been home hours ago. I'm having a hard time keeping
There it
track
is.
of these days.
Fruit,
She's one of those moods, I guess.
Thank you.
Aren't you and Jennifer getting along?
Oh, yeah, great, Mom. We're like a couple of
Oh,
teenagers.
look, double ties. I don't remember that happening.
Yeah, telephone, it's needles.
Dad, it's for you.
All right, well, take down the den.
Makeup was really back
Trapped.
then. So, there you go.
That was pretty fun. So that brings us into our first news item. That was a clip from Back to the Future 2, where they go into the future. They don't go back. They go forward into the future, and into the distant future of the year 2015. And as you could see, Marty had his glasses on, virtual holographic.
Well, and so did the daughter, if you notice, when the phone came in. So
Right.
it's funny. We do have that kind of screen, except we just have it in our pocket. But that may change, right? So what was in the news this week?
All right, Microsoft unveils their HoloLens. This is a big one. If anybody hasn't had a chance, you got to go out and check out. Just Google Microsoft HoloLens. It'll pop up, and you got to watch their video. It obviously is.
Let's go ahead and watch that video.
All right, let's watch it. You want to bring it up? So maybe we
Bring it up.
Look around. Technology is all around us. We use it in every aspect of our lives. It enables us to do amazing things. But what if we could go further? What if we could go beyond the screen? Where your digital world is blended with your real world. Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. New ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
And new ways to create the things we imagine. Because when you change the way you see the world, you can change the world you see. This is Microsoft HoloLens.
Pretty cool.
Pretty cool.
Yeah,
Puts chills in my.
Yeah. So it's a holographic lens. Well, some say maybe holographic, maybe not.
I have strong opinions about that.
I know you do, Mike. I know you do. And so, we'll go right to Microsoft's website here, and we'll kind of pull up what we do know. And so if you go over to Microsoft's website and check out their HoloLens section, you can sign up for email updates. They kind of have some of their marketing PR, some more videos you can check out. Really exciting stuff, just the way we interact with our environment. We bring computing into our reality. So pretty cool. Don't fully understand how they're accomplishing all this yet, but it does. You can kind of check out the hardware. You can kind of get a little sneak preview of what the first gen hardware looks like.
Why don't you leave that up there, and I'll go into my theories real quick. Well, first, let's do a little bit of 101 on what a hologram is. At least back in my day, holograms were based upon using an interference pattern between the original laser and a delayed laser. And this is the important thing. Laser is a coherent light source, meaning of one wavelength at a particular frequency. And what you do is you essentially take two lasers, and the delay creates a phase change, and that is then immersed on an object and then reflected into the what I call a photographic plate. And what you come up with is this very weird pattern. But the cool thing is, once you develop that film, and then you shine the same monochromatic light source into it, either a laser or of a particular wavelength. Let's say if you're using a green laser, if you shine that back into it, then it will project, if it's a translucent film, that image into space. And that's how the term hologram appeared. What you see in the stores and maybe some of the items is a different process where they again use filtered light, but it's projected onto a plate, and it looks like that piece of paper or that film has a 3D object in it, and you can move around, you move your head around and see it. So everybody, I think, have seen one of these in the past. In fact, I've got a couple here that I want to show off. Let me go back to me. So if you can see this, I almost had it. There we go. Can you see my logo in there, Chris?
Not super. Well, yeah, actually, I can kind of see it a little bit. It's obviously green, and you're green screened, so it's kind of coming in and out. Yeah, and so I had a chance to go.
Let me finish up on this. Okay, so this is a real unique process, and I want to talk about this. Is from a company called Zebra Imaging, and they have actually, in my opinion, created the Holy Grail. And as we've seen, and you've seen this up close, it's still in its infancy, but literally they've computed this interference pattern mathematically and printed it upon film. And so instead of having to use lasers, they've literally used the algorithms to create it. As you've seen, it is still blocky. So that's why I know that what they're doing is not a hologram, because first of all, they've pretty much have to use a supercomputer to calculate this, and it doesn't happen in real time. It's over a period of time. It's fairly quick, but it still took, I don't know what the computation, maybe 1 or 2 hours. So again, I don't think that they're computing this stuff in real time as holograms because, one, I have one in my hands. And the other important thing is the way that they're doing it right now is what I consider simulated holograms, where they're mapping the 3D space and then using 3D imagery on top of it to create the perception of a hologram. So that way when you move your head around, you literally can look at the object from multiple angles. So I would consider it a simulated hologram. And then I have my theories on how it works. So Chris, I'll take it back to you, and then I'll talk about what I think is in this technology.
Yeah, well, I think for me, it's a little early to speculate. It's really hard to tell exactly what is in the hardware. There is one section that if you go up to the top here and you click on Get Ready, there's a little FAQ section, and it says, what is a hologram? And they're kind of their definition of what a hologram is and what holography in Wikipedia is obviously a little different. There's varying. I think holography also is more of a general, maybe broad term, And I think that terminology, defines current technology or past technology, and this might actually be new technology or some sort of, and so they might be pushing the actual,
Well, as I said, I'm a strong believer that would be like calling you a girl because we're going to redefine what a human being is. So I'm strong about this. It is not a hologram. It's a simulation of a hologram.
Okay. Yeah. So I think that they're trying to maybe find a word that they can use. So I think at this, it's kind of semantics at this point. But either way, this technology does look like it's pretty unbelievable.
Okay. So let's talk about that a little bit. Some of the things that I've heard from the journalists who've actually tried this is, one, it doesn't look like this, obviously. It's a prototype. The computer is actually worn on their chest because it actually doesn't fit in there yet. But one of the things that I did find in my research last night is that it looks like it's going to be based on a newer version of the Atom chip, something like Cherry Tree or something.
Yeah, that's right.
And which has some extra features in it, and more importantly, it's low power. The other thing is, why did they create a band all the way around the person? So my thoughts are, there's a battery technology, a flexible battery, which we've been using in some of our phones. Well, what if you wrap that battery around the back of your head? Then you'd be able to power this thing for a lengthier period of time. So that's my thoughts there. The other thing is, most of the there's a couple of ways.
They also mentioned 3D built-in spatial.
Okay, who muted us?
So there might actually be a it says that there's built-in spatial sound, so there might actually be some sort of speaker system.
Yeah, actually, they say it's more of a bone conductor. I read that elsewhere, so that'll be interesting. So that's what provides this 360 perception, because you're going directly into the bone. So I'm not surprised with that. I've been reading about that. So the other thing is, well, how are they able to map the surroundings? Well, as you know, I have been working with Occipital, and I have a little video clip that I can run really quick, but I'll get to that in a second. But yeah, you're showing something with your cursor there. I believe that is the projected item. Well, we've talked about in the previous shows, the Connect 2 is based on what they call a time-of-flight laser system. So here we get with our lasers. So we do have lasers here. So, I mean, they're not far from the truth in saying they're deriving holograms, because there is a laser. But it's used like what we talked with the other, the Trimble line of sight 3D scanner, where essentially you scan the area in front of you, and then you can put the time of flight information, which means you determine at the particular point of your laser transmission the image coming back, you measure that time, and then you get an accurate assessment of how much distance. So if you do this over a bunch of points, you can create a fine mesh. Well, the concern I've had, or people have with the Connect 2, is that it's great for this type of thing where you can rapidly determine depth information, but it's not very fine or granular. Well, does it need to be? If you look in the video again, if you go back to it, all you need to do is map roughly the dimensions of the room, and then once you have that, like a flat surface doesn't need that many polygons. Same thing with walls. So with some good algorithms, you can very quickly determine what your room looks like. And that's a technique that other people use. You kind of cheat when you need to, and then you provide the detail when you don't. That's what compression is all about. So that's what we're seeing here. And then obviously NVIDIA has worked very hard to make, with their CUDA cores and their GPU technology, that ability to create transforms on the fly, which also adds to the real-time functionality. The interesting thing is, I mentioned already it's a battery pack, but this only projects in front of you. So I'm wondering, well, what if you map your entire surrounding in real time, meaning front and back? So that way, when you turn around, you're constantly getting a change because you've already mapped the full 3D environment. So when you move around in it, it's not just your front view, it's also your rear view. So I don't know if that's a possibility. Another reason why this has to be a band all the way around the head. But I think that might be a possibility. And then finally, how are they projecting this? If you notice, it's a visor that's, translucent. It looks like a pair of sunglasses. Are we looking at a screen being projected into it through some type of projector technology? Or have they worked with that other company we talked about, which makes that system that projects directly into the eye? There's been some articles that I read that they're actually looking at the eye itself and using that for tracking. Well, if you're already projecting into it, you may already be doing that. So they may have married, because I haven't heard anything else about this company, so maybe they have already purchased this company. It's a rumor, I know. I'm making assumptions here.
Either way,
is that a possibility?
Either way, the demo video, if this thing does only 10% of what they're claiming in the video, it'll be an amazing product. I really definitely am looking forward to seeing some updates on from Microsoft on how this thing works, and I can't wait to get my hands on one.
Neither can I, and obviously, as you know, I'm a VR junkie. But on that note, I want to show this clip that I took when we were at CES, if you don't mind, Chris.
Yeah.
One of the things, and it's been really low key, and I'm surprised for that, and I'm trying to promote it a little bit more. The Occipital, with their sensor, because one thing, it's compact, and I think that's extremely important. And I do know for the fact that the time of flight has also been compressed in size. So if you remember, I created this the other day, and this is based on a VR1, and notice I have the occipital structure sensor embedded using my NEODiMOUNT system. So literally, the phone fits in the side, I have a cable going to it, so we have at least a facsimile of what Microsoft's wanting to do. And it can happen now. In fact, it will happen soon, because I have been in conversation with Jeff of moving forward with that. He's already been tinkering with OpenGL for iOS and created a dual screen little test program. So we are moving in that direction. But I'm going to go ahead and play the little video quick that we did.
So let's talk about it a little bit. What new things have you provided for the structure sensor?
So what we're showing here at the show is new use of the structure sensor. So people are pretty familiar with using it for capturing of objects in 3D. So scanning a person or scanning a room potentially with our room capture app. But what is an interesting use that you normally don't think of is to use the sensor for positional tracking. So instead of just scanning an object for the purpose of having a model, what we're showing here is scanning a room in real time for the purpose of knowing where you are in that space. So we're using the iPad processor, we're using the camera on the iPad, and of course we're using the structure sensor all together to positionally track you. We also are rotationally tracking. So in this demo here, what you're actually able to do, there's nothing special about this room though. This is just any old room. You can actually do this in your living room, but we wanted to have a play space. So we came up with this fictional universe where we've discovered a time rift in a San Francisco backyard. You go into the San Francisco backyard and you use your structure sensor in your iPad to teleport 700 years into the future.
Let them know we're live, though.
That was a time warp, indeed.
That was a time warp.
So you stand right here on the set.
So notice he's got the iPad and he's looking into the environment. Puts it in front
And I'm going to unlock you here. Remember to use your thumbs, always the left and right thumb. Hold your device right. You got these buttons here and over here.
Now, Jeff, this only uses the iPad Air 2, correct?
Yes, this actually will work on the iPad Air 2 or also the iPad Air.
Okay.
If you look down, you just walk past the block. There's a block below you. There it is. If you press that button, you can hold down and grab. Press the grab button, like a window down.
Pointing it down. In real time, it's mapping.
Okay, so do you see where the walls are, Chris?
Yeah, so go over there. You can drop it on this button.
Right. So notice as he's moving, the wall gets closer.
You got it. So now go to the right. And See that arrow?
Except you don't. Yeah, exactly. Except the augmented
The
reality.
gist of it. So, you know, again, this is just a prototype application that they wanted to show off at CES, but, you know, there are other people working with it, and as you know, I've worked closely with Occipital, so I was really excited to find out about a week before, but I couldn't tell anybody. So there are other people working on this, and really all you need to do is have some 3D or real-time 3D mapping technology, and Occipital is one of those companies that have it. There is another one out there, and we talked about them before, and I think that's Soft Kinetics. They are also working on something similar. So there's a lot of people who've got their hats in this, so it'll be very exciting this year. All right, back to you, Chris.
All right, so very cool. Thank you, Mike. And our next item, I just saw this in the news and thought it was worth mentioning, and I'm actually probably going to subscribe to this for a month or two and see how it goes and kind of give you an update on how it goes. But there's a company, if you go to ProtoCrate.com, brand new, and they have this crate. It's kind of like a club, a buyer's club, where you get a $60 retail value worth of 3D printing goodies in a goodie box mailed to your house for $35 a month. And so they are just launching, and you can find out about it at protocrate.com. And then if you click up on the top and click Join Now, you can kind of find out a little bit about it. Here it's trying to add 2 ProtoCrates to my order. So yeah, so it's for $35. You can go, and here let's find out how it works. So you select a plan, and you kind of can tell it, I guess, what kind of stuff that you're looking for, and they put in color chip, a PLA, 1 spool of PLA filament, 3D printed model, mini poster, featured things to print for your new filament, and project supplies and tools, calipers, paint, LED, emery boards, etc., all for less than the average price of 1 spool of filament. So they're kind of bringing a buyer's club type thing to the 3D printing world, and you can find out more about them at protocrate.com.
Excellent. I might try that. Yeah. So let me run right into my next item. And, you know, I was going to have some video from the actual show, but I thought maybe I'd just go right into their website. Do you remember this? You remember Shining 3D? I kind of lingered around hoping to talk to somebody. And they had 2 different scanners. They had a hand style, but they had this thing that, you know, we kind of glossed over, but it is becoming a reality. But the cool thing is, you know, I thought, oh, great, it's just another turntable-based laser scanner. No, it is not. It is a structured light projection system, which means it's probably very similar to the David system. And they've obviously put it into a nice little container here with the rotate. But the thing that I need to emphasize, and I'll go down here and then I'll go into their video. Actually, this is. Did I want to do that? I didn't want to do that. Oh, shoot. Well, I'll come back to it. Is not only do you get this nice little turntable system, you know, like the MakerBot and a few others that are coming out, MatterInform, we talked to them at CES as well. You can remove this and put it on a tripod, or hold it and do freeform, you know, kind of like what I do with the structure sensor. But again, this is another, and the structure sensor is also a projected light source, or as they call it, light pattern. So this works very similar, but also looks very similar to the Artex. So I don't know how different their technology is, but the cool thing is, and let's see if they've got some examples here. I don't have it here. I think it's in their video. Let's see, specification. I looked at the specifications, and the scan speed is actually very nice, less than 3 minutes. If you know, I've got a Next engine, so I compared it to that because I think that's what we need to compare it to. Yeah, the images, if you go out to their website, compare it to the MakerBot laser scanner, which is not the most high-end. So, however, and I'll tell you the price here in a moment because I got an email this morning from them because they're pretty anxious to talk about it. But the resolution is very close to the next engine. In fact, it's a little better than the next engine. And then, you know, if you, again, let me run the video real quick here, and then I'll talk over it. Here we go. So, and you know, this really does exist. Now, interesting, see, it looks like a projector on the back there. So I have a feeling it's very similar to the David scan. But it has a built-in rotating turntable, like many of them, so you can use it. And then notice how they use it on a tripod, which will be difficult to move around like that. Now, here's the thing. They're comparing quality in CAD. I don't think they're going to be offering an STL to solid line. Expensive. But what they're comparing it to is the MakerBot laser. If you notice, I don't know if the resolution would come out here, but it does look more detailed. Can you see that there? Or do I have my view? You need to remind me if I'm still stuck on your image, Chris.
Come again?
Sometimes you have to remind me because I don't switch my camera because I'm looking at another screen. Well, I'll talk to you.
Wow, looks like an. I wonder what the price point is of that scanner.
Ah, glad you asked. The
Glad
price
I asked.
point on this, yeah, the price point on this particular scanner, they're going to be doing a Kickstarter, but you'll be able to purchase it for $8.99. That's going to be what they're launching. But again, it's going to be a Kickstarter. It's going to be coming out soon, and then if you get in the early bird, you can get it in at $7.99. But like many early bird, there's not many at that price point. So it's relatively the same price as the MakerBot, but as you can tell, not only is it quicker, because most laser scanners are fairly slow, but it is also appears to be higher, or I wouldn't say more accurate, but more detail. They also have something that I haven't seen in other Kickstarters, that if you don't chip in all the money for it, let's say if you put in $100, they will give you a voucher for $200 towards your scanner when you are ready to buy it. Have you ever heard of that before, Chris? Where in Kickstarters where you put in a so much and then they double the amount when it comes time to buy it?
No.
I know. I think that's kind of cool because I really can't afford another scanner right now, but I may pitch in $100 knowing that it'll be worth $200 when I'm ready to buy. So I think that's a cool feature. So again, their Kickstarter is coming out soon, so hopefully we can talk to it. So I've still got a few more items, but I did mention that we would have Shon from B9 Creator with us at 10 o'clock. Do you think we could jump right to him, Chris? Or
Yeah.
Okay. So Shon, is that you there?
It's actually Mike Joyce.
Okay, Mike Joyce, and you are the founder and CEO of B9 Creations, right? Or or the B9 Creator, correct?
That's correct. Did you want me to grab Shon? I think let me just send him a quick text because I think he wanted to be here. He wasn't sure when it was going to happen.
Well, we try to do it when we say we're going to do it. As you notice, we interrupted our news items, which is my fault. I have a tendency to blab sometimes.
No worries. Well, while he does that, I could jump into my next news item.
Sounds good.
And I just have one more, which is we've been following this pretty closely, is the construction 3D printing. This is according to CNET on cnet.com.
Oh, I'm glad you covered that because I was going to and ran out of items. So thank you.
So, world's first 3D printed apartment building is constructed. It's a 5-story construction project that happened in Suzhou Industrial Park, and they have some photographs here I think we can check out of an actual 5-story. Well, these look like conceptual, but there is apparently, they have actually gone and done it. We were covering the company that was doing it in the beginning, and here it is. Looks like they're bringing in 3D printed blocks and constructing a 5-story apartment building from the ground up that's 3D printed. So it's happening. It really is happening.
So
some people were skeptical, and you and I, Mike, said we knew it was going to happen.
Yeah, but you know, I was looking through the images. It looks like they actually did the 3D printing at a different location and then transported the sections.
That's right.
Okay.
Yeah, that's right. They did they 3D printed them at the facility in panels. It looks like, and then transported them and basically did a tilt up. It says it saves about 30 and 60% of the construction waste. Obviously, with a concrete tilt up, you have to build forms. Well, with 3D printing, you don't have to build forms. So, and it says it decreases production times by 50 and 70%, labor costs by 50 and 80%, and so a 5-story building was $161,000 to build, which, you know, that seems pretty reasonable for. I mean, that seems a lot less than your typical 5-story. Really kind of interested to get some engineers in there, structural engineers, to really, you know, give their blessing and see how safe the thing is. But nonetheless, pretty exciting time we live in, where we're 3D printing these actual structures. Pretty cool. Here's a great image showing. You can see the actual tilt up.
Mm-hmm.
You know.
Well, that's actually before they painted it too.
Right.
You know, some people said it looks a little rough, but you know, as you said, I think they used recycled consumables. I think was one of the items that they touted as one of the advantages, plus time, and as you said, it is cheaper. So as you mentioned, they do need to look at get a structural engineer to determine the strain. But I've heard in the past that some of the buildings that have gone up in China have gone up so quickly that some of them have actually collapsed because of structural problems. So maybe this is one of the reasons they moved in this direction. The other is it's really cool and it's a good news item. So hats off to them. And as you said, we have covered.
Some say it looks a little rough. I say theirs look a little smooth.
And what do you normally do in building a regular house, especially if you're using, I can't think of the stuff now, but you go through and you run a surface on the top of it. So
right.
Oh well. Okay, so we're not going to keep Michael sitting there any longer listening to us blab. So Shon, are you with him? Yes, you are. So
I am.
So we're going to give you the floor. As you know already, I had a B9. Sadly, as you saw in my email, I gave it up. But I have gone through, painted it my projector black, made my own little logo for it. I was pretty proud of it and had it on the wall. I called it my steampunk SLA printer because it just had that. And when you build things, you kind of have a feeling of possession once you've got it together and it actually works. So I do have to say I did print with it, so I do know that it works well. On that, you're kind of like the father of the what do you want to call it? This consumer version SLA.
The DIY SLA movement.
All right, I'll give you guys the floor.
Sure. Yeah, we actually kickstarted back in, I think it was June of 2012, and I'm not really a 3D printing expert by any means, but in the fall of 2011, I had a friend who, him and I are both in the Experimental Aircraft Association, and he was lamenting at the fact there weren't any new ways to build airplanes, and I said, well, I've heard of this thing called 3D printing, and did a little research, and looked at the extruders that were available at the time, and really didn't like the surface resolution I've seen, and one thing led to another, and I found out that you could harden resins with UV light. So I went about trying to find somebody who could supply us with resin, and there in my basement in Deadwood, South Dakota, I threw together a wooden version of my first 3D printer in about a week, and learned a lot of things. And I had already had a business which gave me some vendors for metal parts, so it wasn't too difficult to CAD the thing up and get a metal prototype there. So I basically went from I wonder what a 3D printer is to I'm kickstarting in about 6 months. So was an exciting time, and like you said, we were kind of the first one, the first resin-based. We used a DLP projector versus a laser to actually kickstart. So that process, in that process, I learned that we had a lot of users who wanted to do castings, and specifically jewelry and then some dental. So we really started focusing on high-resolution and castable printing. And that's probably been the bulk of our sales to date, is the casting industry. So we really, our forte is small, really detailed items. We have a release mechanism which has a very low force compared to just tilting and pulling it off the window. Excuse me. So we've been able to do some pretty incredible small resolutions. And last year we upgraded the projector to an HD projector, and of course that gives us a few more pixels to work with as well.
So tell us what else is new on the forefront of your B9 creators. Is there anything in the woodwork that you guys have been working on that you want to tell our listeners about?
Well, we're certainly working on a lot of things, and we've kind of alluded to this on the list, but we've gone through several iterations on the vat, the container that actually holds the resin. We started with one that was made out of laser cut acrylic and solvent welded together, and that had some limitations, so we then went to a metal one which actually had glass in there, and that's what we've been selling. But we're about to release an injection molded version which will cut the cost down considerably on that. We were finding that a lot of our business users were treating the vat as a consumable. So they'd buy a $120 metal and glass vat. The consumable, which is the coating on the glass, would eventually degrade, and they would have to replace the vat. And they didn't want to recoat it, which is actually a fairly simple process. So they would just buy a whole new vat. So, with an injection molded one, at least we've got the cost down, and you can still recoat it, and I hope a lot of people do. But and we've got a few other things we're working on. One of the things that's really been keeping me busy over the last 6 months is I kind of made a decision, to grow the company. Up until 6 months ago, it was myself and my son in my basement, and we were putting in 16-hour days, 7 days a week, and it was either time to let it die or try to scale it up a bit. So we've moved into Rapid City. We have almost 4,000 square feet in a production facility. We've hired a full-time sales and marketing guy, and I've got a full-time COO who's a mechanical engineer, and we're about to bring on a full-time programmer, and we've got several other production guys, helping us. So, we've been able to scale up our production. One of the things when we priced it initially was I was afraid that I didn't have the time or the production capability to actually assemble them. So the assembled machine, the kit is selling for $34.90, and the assembled machine was considerably more at $54.95. So we recently dropped the price from $54.95 to $45.95, $900 for the assembled machine, because frankly we're able to produce them now. As before, it's just we're labor constrained.
So I have a few questions. One of them is, it looks like you have a new software version, and I ran out of time last night trying to install it and play with it a little bit since I had some experience with the previous version. Can you very quickly tell us what changes you've made? It seemed, I wouldn't say crude, it was like a 3-program process before, and I think it's now consolidated into one. Am I correct in that?
Right. We made that change fairly early on, but we've continued to make improvements. What we're really proud of now there are still basically 3 steps to printing with our software. Number one, we assume you have an STL file, and unlike many 3D printer programs, your STL file can actually consist of literally thousands of smaller STL files that all overlap each other and things like that. And that's important in the jewelry industry, where they'll make a ring out of multiple little components, and they won't Boolean it all together into one clean watertight mesh. They'll have a bunch of overlapping STLs, which can quickly throw a slicer into a tailspin. So
that's true. That's why NetFab is making money.
Yep, exactly. So there's a lot of good utilities out now. But when we first launched, it was a pretty big deal for the people that were struggling with getting a watertight mesh. But our layout software allows you to visually bring in, one or more models. You can go to a support mode where you can just basically point and click and add supports. Or we now have an automatic support generator which will throw supports everywhere, and it'll certainly be supported, but you can still go in there and tweak those supports, delete them or add to them, and move them around. And we do a lot of things visually to show you, for example, where the local minima are, or you can actually cut the thing in half and look inside of it if you got internal supports that you can't see. We call that X-ray vision. So it takes a little bit of learning curve, but it's actually a fairly robust and flexible way of adding supports to your model. So after you lay that out, you can save that layout file, come back to it later and add something to it or modify it. Or, normally the next step is you would slice that layout file, and so when you lay it out, you're kind of determining the resolution in the X-Y plane, and then when you slice it, you're determining the resolution in the Z. The new machine now, you can do 5-micron slicings. That's really fine, and frankly, you hear a lot of 3D printers talking about, oh, well, you can print at 10 microns or you can print at 1 micron or whatever, but the real issue is how accurately can you control your depth of cure, because if you're going to slice at, say, 10 microns, you're really going to have to cure deeper than that to ensure that layer sticks to the previous layer. But if you realistically, you can't control that depth of cure with time. You have to do it with some sort of light blocking or cure blocking element, like we use pigments in ours to absorb those frequencies and limit that depth of cure. So from a practical point of view, we advertise, with our cherry resin, which has the best depth of cure right now, 30 micron.
Well, that's kind of your signature color as well. Many of the models I've seen, including the ones that I have, are in that cherry red.
And that's because our resins actually cure into the visible light range. So you're curing in the blue to violet, and if you see something that's red, well, it's because it's absorbed those frequencies and it's not reflecting them back at you. So you'll see some printers that'll print in clear resin, for example, and they're controlling the depth of cure basically in the beyond the visible range. So they're curing that they have pigments or what have you, but they're clear to the naked eye, but they're blocking the UV frequencies. And we can do that to some extent, but without modifying the projector to put in a UV lamp, it becomes more expensive to do that.
Great. Well, we really appreciate you coming on and giving us this quick rundown. So, with the improvements with the projector and your software, has it improved the performance as far as time that it takes to print an object? Obviously, the details there now, and as you said, your what do you want to call it? Your Z screw has been accurate all along. I don't think that has changed, right? I mean, it's the same. Okay. The other thing too that concerned me, and it's because it made kind of a loud noise and just seemed like it was very violent. I've heard that you've improved your lifting process. If I remember, it was like a solenoid off to the side there that just literally you send it a signal and it
we actually, it's the exact same hardware as the first version. It's all firmware change. We've basically revamped our algorithms controlling that slide motion. Before, we were interested in going as fast as we could because that speeds up the print process. But basically, we've improved the algorithms so that you can still get the full torque available from the motor, but you don't have to be going at full speed. So
that's excellent to hear.
The same machine, but it's much quieter than it was initially.
Excellent. I was always worried about that. I said, man, this thing is just banging away. That can't be good.
And the other thing with the speed, of course, is the time required to cure. And one of the things we're really well known for is that our resin casts really well. I've learned more about casting now than I ever thought I would know, but most of the jewelers like to cast with a fairly soft, what they call an investment, which is like plaster of Paris, right? They pour it around the part, then they burn out the part. Well, the softer stuff, I guess it's cheaper. They're used to using it. It has a very fine surface finish, so it'll really capture the details. But most of your fast resins out there will just destroy it, so you can't get a decent casting. The way you get a decent casting with these gypsum-based investments is you have to have, I don't know, you can call it a high wax content in your resin. Well, that requires a much stronger energy source and a much longer time to cure than a lot of these cheap, fast, what I would call hot or highly reactive resins that are out there. So you'll see these little printers that have a small UV projector in them. They can't cast or they can't cure a resin because they don't have the energy required, or it would take ridiculously long. So we actually have a 280 watt lamp that puts out a high amount of energy in the UV scale. So we can cure these types of castable resins actually faster than anyone else. What I'm excited about is we actually have a black resin coming out soon that's not meant for casting, but it has great material properties, it has low shrinkage, and it cures blindingly fast. So what we're expecting to do is kind of expand our usability in the I guess I'd call it the rapid prototyping or the model making. Not the guys trying to make rings, but the guys who want to do a 8-inch tall bust of somebody, or they want to do a big prototype part for a tooling experiment. Well, whatever. But the black resin is going to allow them to build much faster. We're talking easily an inch an hour or more.
For those people not familiar with the B9 Creator, am I getting an echo on that end, Chris?
No, not now.
Good? Okay,
we're
good. Okay. The B9 Creator, what's the volume size? I mean, it doesn't look like it's any different, so maybe you can tell us really quickly.
That's another unique thing. So we're dealing with the number of pixels. When we talk about resolutions, we're talking about the number of pixels over a certain amount of size. So if you want 30 micron pixels with an HD projector, you can do the math. 1920 by 1080 is going to give you about 1.5 inches by 2 inches. So it's a fairly small XY size. So that's great for jewelers, and that's plenty big. You can shove 8 to 10 rings in a platform that size, and get that 30 micron XY resolution. But we also allow the projector basically to be positioned in 3 separate positions. You have the 30 micron XY, the 50 micron XY, and the 70 micron XY. So at 70 micron XY, your build area in the your build area in the XY is about 4 by 3 inches, and then for all the build areas we have about 8 inches in the Z-axis. So 4 inches by 3 inches by 8 inches at 70 microns XY, and of course you can still slice at 30 microns.
Pretty big. That's a pretty big piece.
Yeah, and
for that resolution.
That's really important as well, because some of the other competitors, they may have a wider build area, but the Z, or the height, is less than yours. So if you want to create taller structures, yours would be the one to go to. The other thing that a lot of people say, oh well, it's 70 microns. Well, that's creeping in on FDM. SLA is different when it comes to printing close to 100 microns because you have a smoother surface. Unlike 100 or even 200, you have ridging because the way the plastics are laid upon each other. You don't have that per se. In fact, I've noticed with my B9. I'm sorry, go ahead.
I'm sorry. Yeah, I was just agreeing with you. You can get a smooth vertical, flat surface, whereas in even a 70 micron layer thickness on FDM is going to have that ridge look.
Correct, and it's really difficult to get around that. Well, again, Michael and Shon, I really appreciate it. Shon, you really didn't say anything, but you're the guy off to the right, and what is your position there? And then we'll kind of wrap it up and let you guys get back to work, and we'll finish our show.
Sure. Well, I'm responsible for helping connect the B9 Creator and its capabilities to new markets and new customers. One of the things Mike mentioned was the black resin that we're getting ready to launch, and as I know you two share a passion for new applications for this technology, and we've already got a couple of great success stories of manufacturing companies who are taking parts that they used to have made overseas that are Delrin or other plastic parts, and simply building those out of our new black resin right in-house, cuts down their lead time, and taking the cost per part from the $100 range to about the $4 range, which means that the upfront cost of implementing advanced manufacturing pays back for them in a matter of a few months. And as we all look to push 3D printing and advanced manufacturing forward, finding those wins where we can get businesses to incorporate the technology, I think will be the key to taking this more mainstream.
Very cool. So Chris, well, I guess since I'm still talking here, so what is your website? So if people want to find out more pricing, more information about your product, and contact you, how would they go about doing that?
They can go to b9c.com.
That's easy. Well, again, thank you for coming on. Chris, you got any?
Well, I had an idea, and I'll let you guys run with it. Here, I think we got some feedback going here.
Yep, you do.
There we go. I had this idea the other day, and I know I'm not the first one probably to think about this, but I thought about a photopolymer. So you could have, you could either overexpose the material. You could put a silver salt, kind of like black and white photography, suspended into your resin, and you could overexpose it by a certain amount to actually tint the resin. You could start with black and white, and then you would actually throw the part into a bath, like sodium thiosulfate, like you do in black and white photography, to fix the resin at the end of the print. So you could actually print like a photographic 3D print. So you could actually have like if you were printing topography or whatever, you could actually maybe have an image projected, kind of like the M-Core Iris in a way, on the planes. So you could actually like kind of overexpose and add a gradient tint to the surface of your 3D image or whatever. So I just had that. I had that thought, and I thought I'd share it with some fellow resin printers and kind of get your take on it or whatnot.
Man, and I thought I was the only mad scientist.
I just had that thought, and I thought I would share it.
So what do you think about that, Mike?
I think we're muted.
Oh, yeah, he can't talk. That's how we.
Now I can't hear him.
Here, let me see if I can bring it back in. Hang on.
Yeah, I unmuted myself.
Good for you.
There's a lot of exciting advancements being made in materials. So things like that, I think, will become more and more likely and more possible. We've looked at mixing a number of different materials into our resin base to change the properties. I hadn't heard the idea of trying to make it more photo or less photoreactive. I think the challenge there would be, if you typically right now, if you overexpose a resin, you increase the depth of cure and reduce the resolution in the z-axis. So I don't know if that's possible or not. Both control the depth of cure and yet change the tinting based on the exposure. But that's an interesting idea.
Yeah, and so and you could also in a way, what you could do is use because DLP is awesome because you actually get this whole gamut of color.
Right.
You could start with black and white, but you could move into color later on and kind of use some of the color photography techniques that they developed later on. I just thought, hey, you probably want to start with the black and white because that was what first happened in photography.
Yeah, or use monochroming process where you use another color, and then because you would have the ultraviolet sensitive, and then you could make something, some type of photo sensitive material that would expose. So then you would have two isolated channels there. So
it's a photopolymer.
Right, we can control the frequency of the light that's hitting each different pixel. So if we had a material where we could cure it to a different color based on the light that we're shining on it, that'd be quite the exciting thing. I don't think it's out there yet, but
you heard it here first. All things 3D. Okay, so we've got to move on. Again, thank you guys for having coming on.
Thanks.
Really appreciate it. And again, it was b9c.com.
Yep.
All right, so go check them out. B9 Creator. It's a great little DLP SLA device.
It's not little. Let's keep that. And the other thing, I wanted to really point out, if you look in the image there, some people don't realize that you don't have to have it on a stand. In fact, I removed the stand and mounted it on my wall. So if you want some nice-looking retro steampunk art to put on your wall, you may never use it, but it looks cool on your wall. There you go. Okay. All right. On to the next item, Chris.
Okay. So I guess we are at our projects for the week, right?
I got one more item. I'll bring it up really quick, and then we'll get it. I wanted to bring this up since we were talking about printing. It was in the news before, but it really looks like they're going to move forward with it. I've applied for a beta on it, but using full color, but they're using it differently. Instead of using different colored filaments, they're injecting some type of dye into the filament as it's printing. There's a little video if you want to go out to their website. You know, since we're running short, maybe I'll just bring it up. But I think it's really cool the process they're going with, and I think they converted a Robo 3D printer into using this. So, really going to keep an eye on this. This looks like a really revolutionary color process. But then, you know, we do have this new DLP process that I just heard about on the show All Things 3D, where they're looking at using full color processing by different wavelengths from a DLP projector. So we'll see how that works out too. No, just kidding. Okay, moving on here.
I thought it was a good idea.
Yeah, so there's the website. You can go out to spectrum3d.com. All right, back to you, Chris.
All right, well, this is our time of our program where we can talk about what we're working on currently at our offices, because we live and breathe for this. So my project for the week has been, I am starting to work on my upgrade. I run a Rostock Max, or I have a Rostock Max, but currently sitting on the shelf since I got my Lulzbot TAS 4, because the Lulzbot just, the TAS 4 just, I mean, it really is just a workhorse. It's one of the most incredible 3D printers to date that I can vouch for. Rostock has been a great printer. I've printed a lot with it, the V1. It has a Bowden drive. So some of the materials you're kind of lacking, it's lacking in the materials realm. However, there is this new V2 upgrade kit. So for $450 you can upgrade your Rostock, and then I'm also upgrading to an E3D all-metal V6 hot end. So
that looks...
Yeah, doesn't that look sweet? And one of the coolest cool parts is from MatterHackers.com, which these guys, really, my hat goes off to these guys because they
just young guys say, they rock.
They do, they rock. And they also sell for $8. You can buy a E3D hot end mount for different printers. They have 3 different ones that are available for the E3D hot end for sale for $8. The 3D file, I just printed mine out. So here they are for the stock. They've got them, so these are the mounts. I thought, hey, for $8, saves me an hour of CAD time or any figuring.
Mm-hmm.
They've already done all the figuring and probably gone through multiple iterations. And, you know, MatterHackers, everything I've ever bought from them has been really worthwhile. So they have a little upgrade to the E3D hot end. So I have an E3D hot end on the way. I just received my V2 pack from CNC, so my Rostock Max is on the workbench now, and I will be upgrading it this next week. And so maybe by next Friday I'll have a little update letting you know where I'm at with that and how it's printing.
I think your Rostock appreciates that. I remember it was a little sad back there. It was dripping plastic as though it were crying because you
it will be revived.
Yes, so thank you.
Yeah.
You know, we should create like the animal shelter with the 3D printer shelter. So, you know,
where we're a no-kill shelter.
Exactly. Yeah, you got an old 3D printer, send it our way. Actually, that would be an interesting business. Find a home for it. So don't let it just sit there collecting dust. Send it to us.
Yeah.
We'll take care of it. Okay, on to my next item, if I have one. I lost my cursor. Damn it. God. Luckily, I have a touch screen, so I can use it. All right. Update. This is the NEODiMOUNT iPhone 6 Plus case. It is ready for production. In fact, Chris is doing a couple of production prototypes for me as we speak, I hope. And
Indeed, I am.
should have them in the mail so I can actually send those out. But this is the white prototype version that I did on my Maker Gear M2, which I think is a very sweet machine now, using Polymax. I really like that material. I'm going to have to buy you some, Chris, because it is a super material. You'll have to try it yourself, maybe on your
Awesome.
Rostock Mac. But again, it's ready, and the important thing about the NEODiMOUNT, there you go. That quick, you can remove your structure sensor from your case. Pretty cool. Okay, on to that. I want to bring up, we had a, here, I'll bring it over here. We had a demo, not demo, the company Protopasta. We had Dustin on earlier because he couldn't make it as our guest crasher, so I'm not going to really go through a lot of the video. I'll do it really quick. That ran, and I'll bring that down a little bit. But we had him on, it was Wednesday, and we kind of talked about some new material very quickly. They've got a conductive PLA, they have a stainless steel PLA, and a magnetic iron PLA. Gosh, isn't that kind of neat?
You're
In
listening
our
to
own
All
little
Things
video.
3D,
How funny.
where we talk about the world
but
of
we,
fabricating, designing,
actually
and
talked to
capturing
Dustin
in
about
the
these materials and talked
and
about
our
some of the
iron,
things. So if you have some time, jump back over and listen to
some
Dustin if you
cool
haven't
surface
already.
finish
He's
properties,
got some good
and it's magnetic.
updates
You can,
and
like,
about the
patina the
material.
parts
And
with
they had a
some solution to
contest.
rust it,
The print
and
labels.
that's what I'm
So
gonna
you
ask.
see some new cool user art on there, right? There's
Yeah, it
schools,
does.
so come
And it
out and
turns out
support
it
them. They've
works
got some
pretty
neat
well.
stuff out there.
If that's the
I
aesthetic
personally am
that you
waiting
want.
for my
If
conductive
you want
filament. It didn't come in
something
yet.
that doesn't
I was
corrode,
hoping to
the
actually
stainless
show it.
lets you
I have a use for it
polish
when I'm
it,
printing conductive or
using standard
anti-static
polishing
beds
techniques
for
like a
a
buff and
proprietary chip.
You know, kind of like
So
bronze
hopefully
fill
I'll get that
those
soon.
into
Okay,
a,
well that's it for that particular item. And let's see what else I have. So that actually will be my products, as well as the B9 that we talked about today. And let's get into what's coming up. We have coming up the Consumer Electronics Show, which we just went through, so I guess that's no longer coming up, and then the Inside 3D Printing Conference in Singapore. So if you're in Singapore, head out there. Looks like it's a very, well, it's $20 to $4.99. I'm assuming the expo is $20, and then if you want to go to any of the conferences. And then in our own neck of the woods, down in Burbank, California, and we mentioned it last week, we had the 3D Printing World Expo. I'm still trying to figure out if I'm going to go next week, but I really would like to. I may make it into a dual trip. I've got a client down there that I'm working on some software that hopefully in the next couple of weeks I'll be able to introduce to you. But looks like an interesting show. Sadly, it comes immediately after CES, and CES had a lot of 3D printer exposures, so I hope that there's some new things. As mentioned earlier, ZBrush, since they're in Burbank or in the vicinity, does play a big part, and they'll be showing off ZBrush. Actually, it's not ZBrush. What's the name of the company? Pixelogic? Does that sound right? I think it's yeah, Pixelogic, but they make a product called ZBrush, and then a free product called Sculptress. So if you're familiar with either of those two, they give some, here it is, 3D artists go ahead head-to-head in the live ZBrush sculpt-off. That would be pretty cool. I'd like to get some footage of that. That would be fun. And there are some extremely talented people out there that use ZBrush, creating some really good things in a lot of the movies you've seen. So if you have some time, you're in LA, that seems like a no-brainer. If you're anywhere else and need an excuse to head out to Burbank, this in the past has been a really good show. So on that, I think we are done for the day. Unless you got anything else, Chris?
I just have to mention, this came off my Lulzbot, massive Anchor Watt print.
I know, you showed me that the other day.
And I just have to say that this would not be possible without MatterControl's auto bed leveling or doing an intense amount of bed leveling by hand. This is ABS too, so notorious for warping. That's on the Lulzbot 4. Yeah, the bottom is just perfect.
yank your webcam off, and why don't you show us? You've got something printing over there right now. Kind of give us a description of what you need to do, because you said it has some, not necessarily auto leveling, but a, what do you call it, a program function that you go through very quickly to ensure that it's...
Yeah, so so MatterControl has a really cool feature over here in the configuration setting. If you head over, right now I have it printing, but if you go to your automatic print leveling, you can actually configure it, and it's about a 3-minute process. You do need to set your Z height, obviously, of the nozzle, so you got to be roughly, you got to have the rough 0 of where you want your nozzle height to be from the beginning, and then what you can do is you can actually go through an auto bed leveling procedure, and then MatterControl will take it from there and auto level your prints for you. It is really, really a nice
When you
feature.
say auto levels, so there is something built into the head that allows it to determine the proper gap distance from the bed?
No, it's a procedure. You do it by hand. You do it manually. So you click a button on the computer, bring the nozzle down, 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 down. Then you back it off 1 notch, down, 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 down. Finer, and you just do it 3 times, and it goes on it basically in a triangle on your build platter, and it can figure out how to.
So you don't have to adjust any screws on the bed itself. Is that what I'm understanding?
No
okay,
need.
So everything
no
is
need.
done by doing delta adjustments in the software. So
Yeah, and obviously the more level your print bed is starting off, mine was already fairly level. So, but I don't think that a print this large, especially out of ABS, would be possible without either hours of tinkering to level the bed or having some sort of auto leveling procedure. So I'm really happy to see people in the software and not have a Hall effect sensor or some weird janky thing that's on the head. Forget all that. This is in the software. It runs all your G code through this procedure and will adjust your G code accordingly. You can actually have even the files that you slice to send to the SD card. You can have it run through that procedure automatically, and then you can output that G code. So even if your printer is not connected to your computer, you can still have it automatically level. It's really awesome. I really enjoy the MatterControl. I will plug them. Matter Hackers has been making my life pretty dang easy.
So to be clear in my own head, the TAS4 has a 3-point manual bed adjustment system?
It actually has a 4-point on each corner of the bed.
So
and it's real simple to really get it. To really get it, you just put the head to one corner, and the tape. Then you adjust little set screws. There's 4 little set screws that are right on the top, little 3mm hex bolts, and they're super or little Allen screws, and they're super easy to adjust. And so to get it close, that's what I do. Is to get it close, I use those, and then I use the MatterControl to do the auto bed leveling to really get it perfect.
So you get it to what, 0.1 millimeter? Is that correct, or 0.01 millimeter with the card or business card or whatever?
Yeah, I do a sheet of just a sheet of standard laser printer paper.
Okay, so like the standard process, you drag it through a little tension or friction on it.
Yeah,
and you're good to go.
And if you go on Lulzbot's website, or even if you look at CME CNC's latest, let's see, they have a document, and they actually use Lulzbot. They give you Lulzbot credit. Here, I can show it here.
So then the MatterControl can actually, that process can be used with other printers. It's not specific to the Lulzbot, right?
So this is kind of like showing you the correct, the middle one is what you're shooting for. You want it to adhere to the bed, but you don't want it to be too squished. Mine's kind of like the left right now, whereas I think it needs to be more in the middle. But yeah, I like to have it really adhere to the bed so I don't get a lot of warping, but those, my parts are turning out great, so I'm not really worried about it.
Yeah. Well, I think you would really want to concern yourself with that if you need accuracy in the Z. You know, obviously what you printed there, even though it's flat, looks good, you're not really concerned about the accuracy of the Z. So I'm thinking that if you really need parts to be precise in the Z-axis, that you would ensure that you level it properly. So that, in fact, like some of the parts that I printed where I haven't kept that in mind, my parts, let's say like a cube isn't necessarily a cube because of something like that. So yeah, it's very important. Well, I'm going to have to try this MatterControl. You know,
it works really good.
I have to say I'm kind of a simplified 3D geek right now, and I do like their bed wizard. It's, you know, fairly easy and it's customizable as well. And so I use that on a regular basis, and but I will have to give that a try. Okay, on that note, we are again running past an hour, so.
All right. Well, thanks again to our listeners and our guest crashers from B9 Creators. You can check them out at b9c.com.
And the Back to the Future Dustin guest crash from 2 days ago with ProtoCrate.
Right. All right, and we definitely thank our listeners for joining us, and we will see you next time on All Things 3D.
Bye.